We're going to be taking a look at this lab, blind OS command injection with output redirection. Now, we covered blind OS command injection in the previous lab where we were able to provoke a time delay by injecting commands into the underlying operating system. It may be worth checking out that lab before this one, since the initial attack vector is the same, and that lab is entitled blind OS command injection with time delays. So the vulnerability exists within the submit feedback form. So we're just going to capture the post request by providing some arbitrary information to the submit feedback form. We can see a copy of the post request, and we know that the value of the email field is going to be directly injected into an OS level command. Now, you'll have seen from the previous lab that we can inject into this by making use of the OR operator in Linux, the double pipe character. In this case, we're going to make use of the whoami command. We had to use the ping command in the previous lab because we weren't going to be able to access the output. So the only evidence that we've actually injected into the OS was a time delay. In this case, we're hoping to be able to retrieve the actual response from the underlying web app. So in this case, we can actually make use of whoami. Then going to make use of the redirection operator in Linux. So this is going to be a right angle bracket. So it's going to write this output or redirect this output to the location that we specify. Now, it just so happens that from browsing the web app, we know that there is a public directory from where images are served. And in this case, it's going to be var www images. So the idea here is that we are going to write or redirect this output to a file, which we can give an arbitrary name. We'll call it output.txt. Hopefully the response will be saved in a text file in the var www images directory. And since this is something that's public facing, we should hopefully just be able to browse to that directory by use of a crafted URL get request and then access the response from the OS level command. Now we need to end our injection with another double pipe character. This was explained in the previous lab. So we've sent this to the back end. Here is the response. Now the next step is to see whether the command was successful. And if it was, we're hoping that there is a new text file in var www images output.txt. So you can see here when we browse to the directory using /image with the key value pair file name equals output.txt, we actually see the response from the operating system command. Now, how did we know to navigate to this directory? Well, if we take a look at any image and choose open in new tab, we can see that the URL is /image, and as part of the query string, we directly reference the file name. So we have file name equals 73.jpg. So it's very clear that this part of the lab simply takes the name of the file. And if it's in that directory, it's going to display the contents of that file. So all we did is change the file name parameter to output.txt, and we can see it reads the value of that text file, which in this case corresponds to the operating system command output. So although this was originally blind OS command injection, making use of the output redirection technique, we now have a way of accessing the response. As with most OS command injection vulnerabilities, the simple solution is don't take user input and use it directly as part of an OS level command. All right, hope it was helpful. Make sure to check out the previous lab if you didn't already, since it lays some of the groundwork for understanding this lab. Thanks for checking out the content, and I'll catch you guys in the next lab.